Welcome friends, Igor is here, and in this video we will talk about the null space of a matrix. In this lesson we will define the null space of a matrix and compute null spaces of several matrices. Let's get started. The solution set to a homogeneous linear system has an additional structure which we do not yet see. This additional structure is encoded in the term space. We will start slowly poking at this structure, and our understanding of this structure will grow as this course progresses. The null space of a matrix is the solution set to the homogeneous linear system with A as the coefficient matrix. Let's observe that the null space of any matrix is always non-empty. It contains at least the zero vector, which is the trivial solution to a homogeneous linear system. Let's try to compute the null space of the following 3x5 matrix. To do this, we simply need to solve the homogeneous linear system with A as the coefficient matrix. We start by constructing the augmented matrix of this homogeneous linear system. Then we find the reduced row echelon form of this matrix, and let's write the equations which correspond to non-zero rows of the reduced row echelon form. Then we are going to solve each equation for the corresponding dependent variable, and we see that we have two free variables, x3 and x5. We use these two free variables to describe the infinite solution set of the homogeneous linear system. But according to the definition of the null space of the matrix, this solution set is the null space of the matrix A. In other words, to find the null space of the matrix, we just need to construct the corresponding homogeneous linear system and solve this system. The solution set we obtain is the null space of the matrix. Here is another example. Let's look at the following 4x3 matrix. We construct and reduce the augmented matrix of the homogeneous linear system, where C is the coefficient matrix. But in this case there are no free variables, and therefore the only solution to the homogeneous linear system with C as the coefficient matrix is the trivial solution. This means the null space of C contains only the zero vector. Let's make a couple of general observations. First of all, we know that every homogeneous linear system is always consistent. Therefore, it has either a unique solution, which is the trivial solution, the zero vector, or infinitely many solutions. Since the null space of a matrix is a solution set to a homogeneous linear system, it means that the null space of a matrix is either only the zero vector, or it is an infinite set, which in particular includes the zero vector. If you found this video useful, please like and subscribe to help others discover this content. In the next video in this series, we will define and study non-singular matrices. I will see you later.